Let me introduce you to cluster analysis. This is going to be a short tutorial where I'll be talking about, first of all, what do you mean by a cluster, how it is different from a decision tree. Then I'm going to talk about different distance and linkage functions to explain you what is a distance function, what is a linkage function, and what is their usage, what is a hierarchical clustering, what is a Scree plot and Dendogram, what is a non-hierarchical clustering, and how can you learn it in detail. So here I'm just going to touch upon all these things very briefly. So first thing first, let's say in a particular institute you have 9 students PQR, XYZ, ABC. This is their score in physics and in the math. So Q has got 20 in physics and 15 in math. Now by very look, it looks like they are actually, if you see ABC, looks like they are the high scoring guys in both physics and math. XYJ, it looks like they are the guys who have scored somewhere close to 15 in physics and somewhere close to 45. Now this is actually an artificial data which has been created so that you can grasp the concepts very well. If you plot them, now you take a look. It looks like all these three objects are somewhere who are obtaining some marks and they are behaving in most similar way. These are the guys who are in midway, and all these three are similar in some sense, and these three are similar in some sense. The other thing is that though they are similar, all these three are similar to each other, any object of this group is very dissimilar to any object of this group. So these three are similar to each other. These three are similar to each other. These are X, Y, Z. A, B, C are similar to each other. But if you take any group, any object from this group, A, B or C, and you take any object of this group or this group, they are very dissimilar. So this introduces you to the concept of that these are the group which are homogeneous within and heterogeneous across. And how you thought that they are similar? By just very look, you plotted them based on these input parameters, physics and math. And by look itself looks like they are similar, they are similar, they are similar, right? So if you think of, you have just developed a cluster. These three are the cluster, and what is their properties? The properties are that they are natural group, they are natural grouping of similar objects based on input parameters. So if you have decided physics and math, this is how the cluster will develop. What you need to understand, if you add a third dimension altogether, the cluster can change. If you had altogether, let's say physics, math, let's say chemistry and English, you keep adding other parameters, probably this grouping that whatever PQR you have got, the cluster may change. So the natural grouping you are seeing is based on these input parameters, and based on these input parameters it is having one property, that they are homogeneous within and heterogeneous across. Heterogeneous across means any object of this group or this cluster is very dissimilar to any object or any observation of this particular group. Now let's take a look at what you have just learned. What you need to understand, in cluster analysis there was no objective function. There was nothing like a dependent variable which you were trying to forecast. There was nothing like, okay, who are the people who defaulted and who are the people who will not default, who are the people who have responded and who are not responded. So there is no dependent variable here. What you have is just the input parameters, just the input variables, and based on that it is trying to develop natural grouping on its own. So it is called subjective segmentation just because it doesn't have a objective function, and the segmentation develops on its own based on the values of input variables. So whatever input variable you have taken, let's say in this case physics and math, whatever the actual values it is taking for each observation, based on that segmentation develops on its own. That's why it is called unsupervised learning, because you are not trying to set the pattern. It is just detecting pattern on its own. And usually, like, you decide how to deal with segment once you have developed the segments and have understood it, what segments are trying to say. So if you think of how it is different from decision tree, in decision tree, let's say, the very much the way, like, you develop shade or card tree, there you have a objective function. Let's say if the dependent variable is 0, 1, you have a dependent variable and you are trying to forecast, find out those variables which are able to differentiate the population in such a way that one side you have more 1, another side you have less 1. If you think of here, you started with 6.6% 1, and in this case you are getting 63% 1, and in this case 5.7% 1. So what you are trying to differentiate, you are trying to create a group which has as much possible differentiable a dependent variable rate. So differentiate a responding rate. So this is all you are trying to find out. It's based on which are the variable which are closely associated with the dependent variable. Your whole purpose is that, okay, how can you explain the dependent variable better? So in this case, if you think of out of 221, this out of 3346, the bad rate here was 6.6. Here the bad rate is actually 63%, and that's what you are trying to create the groups which are as dissimilar as possible in terms of bad rate. So here there is a dependent variable, and that's what, and the whole algorithm is based on which are the variable which are closely associated with the dependent variable, which is not the case with the cluster analysis. Cluster analysis doesn't have a dependent variable at all. It is just grouping based on the independent variables. Now, how do you know that which are the two objects which are similar to each other? Like, for example, when I showed you in the graph last time that, okay, this is how it is looking like, this is how the cluster is looking like. Here you looked at and you said they are looking similar to each other. But what is the mathematical way of finding that which are the group which are similar to each other? So the distance, how do you calculate distance between 2 points? This is the formula. So if you have p parameters, it's xi1 minus xj1, where I is the first object, j is the second object, xi2 minus xj2, and you are taking square of all of them, and then you are taking square root. That's what is called Euclidean distance. It is most popular. If you think of, if you had just two parameters, u1 and v1, or u and v, then u1 minus u2 whole square, v1 minus v2 whole square, and square root of that will give you the distance. In a way, it is a straight line distance. If a bird would have to go from this location to this location, that's how it will fly. So if you think of it's a straight line distance, which shows that, okay, if you do not have a restriction, do not have to go in the roadways or anything, that's how you will go. So Euclidean distance is the most popular method of finding the distance between two objects. Now let me talk about how do you find the distance between two clusters. This is a very important thing, and when you talk about linkage function is all about how do you calculate distance between two clusters. What you need to understand in the cluster analysis, like especially in hierarchical, when you are starting, you have first time you have only observations, each object is a cluster, but next time you have a group which has 3-4 objects, or another group which can have 2 objects, and then how do you find distance between two cluster? There are different methods by which you can calculate distance between different clusters. One is the simple linkage, where you are taking any object from this group and any object from this group, and you are taking the closest two objects. So when you are taking the observation from each of them, one observation, which are the closest to each other, so you actually can have a number of, you can take this distance from all the points here, this object distance from all the points, and then you take the shortest one, That's what is called single linkage. So single linkage is all about finding the distance between any of the two objects, where one object is from cluster 1, another object is from cluster 2, and the shortest distance. The opposite of this is actually complete linkage. We are trying to find the distance between two farthest point in the clusters. So you'll take the point which is the farthest from there, and you'll take the point from another cluster which is the farthest. So if you think of, if you have gone by this method, and if you say that these two clusters are similar, the all other objects are bound to be even closer than that, because you have taken the farthest point, and if they are closer to something, then you decide upon, okay, these two clusters are similar or not. So that's why it is called complete linkage. There are many other linkage formula that is in place. So that's what was you understood how to calculate the distance between objects and how to calculate distance between the clusters. That's what you are doing by using linkage function. Now let me talk about hierarchical clustering. It's all about, you are usually applied when you have less observations, usually less than 100 observations. It shows at each stage that how each observation is linking with another. It shows by Dendogram, which I am going to talk about. Proc cluster is the command that you use in SAS for this hierarchical clustering. And Dendogram and Scree plot are useful for the same. So let me quickly talk about what is Scree plot. A Scree plot is actually number of cluster and within cluster variance. So here you have 8 clusters, 7 clusters, 6 clusters, like that. And here you have within group variance. So you take all the clusters, and within each cluster you find the variance, and you sum up all the variance, all the within group variances. That's what you'll be putting here. So this is within cluster variance and the number of clusters. If you plot it this way, it actually tells you that, okay, if you now understand this way, when you have just one cluster, it means each and every observation is within that cluster, right? Only one cluster means all observations are within that cluster. It means at that time total variance is what you are going to see, because that's what you'll take actually the mean and the total variance will come here. So if you think of within group variance is increasing, right? And there at one place you are getting an elbow point. That elbow point tells you that what is the optimal number of clusters that you should take. Why it is? Because if you think of, it means that you have created almost homogeneous groups. That's why within group clusters, within group variance has not changed. And these are heterogeneous across, because the within group variances are less. So that's why the between variance is bound to be higher, because between variance will be total variance minus within variance in this particular case. So if you think of, the point where you get elbow when you are plotting within group variance, which is actually sum of within group variance. So within each cluster you are finding within cluster variance, and then you are summing it up and putting it here. Then the elbow point tells you optimal number of cluster that you should take. That was all about Scree plot. Now let me talk about Dendogram. In Dendogram, it actually tells you that how the cluster is forming in each step. And if you know how to read it, if you think of, it is saying that first time it combined 1 and 3 together. Then it combined 2 and 5. Then the next step it combined this group, this cluster 2 and 5 to 4. That's what has come here. Then in the next step it has combined this group 1, 3 and this group which is 2, 5, 4. And in the next time it has combined the last object 6. So it is telling you how the cluster is forming in each step. It has taken 1, 2, 3 and 4 steps. What is K means clustering? K means clustering is non-hierarchical, and you do it when you have huge number of observations. The algorithm is very different here. In the beginning only you decide that how many clusters you require. You require 8 clusters, 9 clusters, 10 clusters. That's what is K. So K is the number of clusters that you need. Once you have the k, that okay, I am looking for 8 clusters, then you actually follow the 4-step process. The first step is that you partition the whole data sets, the whole objects, into k non-empty sets. What you need to keep in mind, non-empty sets. So each of the k subsets should have some observations. Next, you compute the seed point for each of the clusters. So in each of the cluster you have several objects. You calculate their centroid, you calculate their seed point. That's what gives you the seed. That's you calculate their mean for each of the objects. So in a, let's say in a particular non-empty subset, let's say 5th subset, you have say 15 observations. You are taking the centroid of the 15 observations. So essentially, if it has say x and y dimension, it will be x1, x2, x3, x4 till x15 divided by 15. That will give the first centroid, and the second centroid you will find y1 plus y2 plus y3 till y15 divided by 15. That will give you the second parameter of the centroid. So that's how you are calculating seed point for each of the k non-empty subset. Now what you will do, you will assign each object to the cluster with the nearest seed point. So if you think of, now you have got different seed points. Now you will start actually passing each observation at a time, and for each observation you will calculate it is closer to the first seed or second seed or third seed, like that. In reality, in the first go you will get k seeds, and wherever it is the closest you will combine, you will put that into that particular cluster. Once you have done that, again you will go back to the step 2. So essentially you will calculate the seed point once again, and then again, so essentially if you think of, in each step you are calculating the centroid again, and then passing each observation one at a time, calculating from where it is the closest, and you are putting it into the group where it is the closest. You will stop when the assignment does not change. So essentially, like the observations which are in cluster 5 is in cluster 5 only. The observations which are in cluster 7 is in cluster 7 only, which means the centroid in different steps are not changing. That's the point, that's the time when you need to stop. It means assignments is not changing and you have reached to the optimal. You have reached to the final subset. In k-means clustering, you will never know it's optimal or not. You use proc fast class command in SAS. That's just to let you know where to use proc cluster and where to use proc fast class. You can't use proc clustering when the number of observations are huge, just because it becomes computationally impossible. Now, how can you learn it in more detail? Essentially when you run SAS, do proc cluster or proc fast class, it produces lot of statistics. How can you understand each step of SAS output? How can you understand in each step what SAS is doing, how it is combining? That's a detailed thing that you need to understand. I have put a detailed tutorial for this in udemy.com. How can you do that? You need to go to udemy.com. You just put search cluster and you need to search course by my name and you will find it. Let me show you how it is. So I'll just go to the Udemy. So let me just go to the udemy.com. You put here cluster. This is the class by me, Gopal Prasad Malakar. If you click on here you will have all those things that I'm talking in great detail. So for example, you'll understand, first of all, you'll understand the intuitive understanding of cluster analysis, then how it has been applied in different industry. Then you are going to understand hierarchical clustering, and there will be an Excel sheet where I'll be working with the SAS formula, and so that I can, how can you use Excel and understand the SAS output very well. So that's one of the big part where you apply it in SAS, then take a look at the output and you try to see how the formulas are working in SAS using Excel. So up to great extent we will try to recreate the whole SAS computation in Excel. Then you are seeing the Scree plot, you are seeing when to standardize variable, what is Dendogram, and for a practical case observations, We'll be developing this and we'll see the Dendogram, how the SAS produces and what it is trying to do. So it talks about hierarchical, it talks about when to go for non-hierarchical, why to go for non-hierarchical. Then it talks about non-hierarchical clustering in great detail. There are some things that you can take a look, preview, it will play, it will give you an example that, okay, how can you take a look at how the videos are getting explained. On the right hand side, there will be download button wherever the Excel, there is associated Excel or something, which you can click on. There will be Excel associated, I think in lecture 11, this particular place, and in other places. So you'll find a download right side which you can download. I guess try to take a look at what is available in this particular place, which will give you cluster analysis detail, cluster analysis motivation theory and practical application in great detail. Thank you.